All right, good morning, or I guess afternoon for 5th and 7th hours. I apologize. I'm not here today. My daycare is closed, so you're going to have to do with the video today. So the first thing that I want to let you guys know, we are going to spend all week on this section. So today is probably the most important one, which is why it was just so hard to miss today. But just keep in mind that we are going to continue to practice and practice and practice this all week. So if it doesn't quite sink in today over the video, lots of practice coming your way. So what we're going to move into in chapter 10 is we are talking about radicals. Now, a radical, haven't really heard of it called a radical before. You've probably heard it called a square root. For purposes of this section, same thing, okay? A square root is a more specific name for a certain type of radical, but we're going to use the word radical. So let's get into our notes here. So what we're going to talk about today is how to simplify radicals. Now, in the end, hopefully, what we're going to do is we're going to get comfortable enough with radicals that we know by looking at a fraction, for the most part, if it's in simplest form. So like, if you had 12 over 15, that's not in simplest form because 12 and 15 have a common factor. You could divide out a 2 from both of those. Sorry, not a 2. You could divide out a 3 from both of those and you'd get 4 over 5. And then you would know 4 over 5 is in simplest form because they don't have anything in common. And there were other things as you were starting out with fractions that you would know if it was in simplest form or not. But we've kind of become comfortable with fractions knowing that. So radicals have also these special rules when they're in simplest form or not. And there's 3 of them that we are going to talk about this week. So the first thing is that there can be no perfect square factors under the radical sign. We'll talk about that here in just a second. Okay. Second thing, there can be no fractions. No fractions under the radical sign. And third, there can be no radicals in the denominator. Okay, so first thing, no perfect square factors under the radical sign. Second, no fractions under the radical. And third, no radicals in the denominator. Now, out of these 3 rules, we are just going to talk about the first one today. We will cover the other 2 actually on Wednesday. So let's talk about the no perfect square factors under the radical. So what I have down here is I have the list of perfect squares. So the perfect squares are 1, 4, 9, 16, 25, and so on. And I know I ended the list with 225, but you could keep going. There's more than that. What perfect square factors are is that if you take the square root of any of these numbers, it will come out as an integer. Or actually a whole number technically. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4, and so on. Another way you could get these numbers is you could take 1 squared to give you 1. You could take 2 squared to give you 4. 3 squared to give you 9, and so on. So I stopped at 15 squared, but you could keep going to get 16 squared. So if the number under the radical has one of these numbers as a factor, so remember from whenever we were doing our factoring unit, a factor is something that can be multiplied together to give you that number. So basically, if the number under the radical sign can be divided by any of these numbers, it's not in simplest form. So part of what we're doing today is just recognizing that, hey, it's in simplest form, or no, it's not in simplest form. But another big part of what we're doing today is we have to know how to simplify it if it is not in simplest form. So I'm going to teach you 2 methods. One of them is super simple. It's super easy, but it can take a little bit longer than the second method, which is a little bit tougher. But I'm going to show you both methods, and I'll let you guys choose which one you want to use. So the first super simple, easier method is called the cake method. Now, there are 5 rules for the cake method. They're not going to make any sense until we look at an example, but I'm going to go ahead and read them off for you. So the 5 rules for the cake method. Number 1, only divide out prime numbers. Now let's pause there for a second because we might need to remind ourselves what prime numbers are. So we talked about how to factor numbers or factors of numbers. prime numbers are going to be numbers that have exactly two factors, 1 and itself. In other words, these are numbers that can only be divided by itself and 1. So for example, the smallest prime number is 2, because the only thing you can divide out of 2 is 2 and 1. 3 is also a prime number, and you might want to write these down because you are going to need these. 4 is not a prime number, because yes, you can divide 4 by 4 and by 1, but you can also take 4 divided by 2. So if it has that extra factor there, it is not a prime number. But I could do 5, because the only thing you can divide out of 5 is 5. 6 is not prime, right, because you have 2 and 3 that can be divided into 6. But we could do 7. Keep in mind that as I move up and I talk about 8, 8's not a prime number, 10's not a prime number, 12, 14, all of these even numbers, not prime numbers, because they're even. They can be divided by 2. So we can just skip the even numbers. 9 is not, but we could do 11, 13, 15 wouldn't be prime, but you could do 17, 19, 21 is not, but 23 is. And kind of like the perfect squares, you could keep going. The prime numbers, the list of prime numbers is endless, but for purposes of this lesson, you probably won't need to go above probably 13. Okay, so first rule, we're only going to divide out a number on this list. Second thing, don't stop until you get to 1. Third thing, circle pairs. Fourth thing, pairs go on the outside. And then fifth thing, numbers without a pair stay inside. So let's do this example here. So the square root of 288. So here's how the cake method works. Down here at the bottom of this box, we're going to write out 288. The first rule says only divide out prime numbers. So what we're going to do is we're going to do like old school division, right? Back in primary school or elementary school, whenever you did this. And what you're going to do is you're going to find a prime number that you can divide out of 288. So a number on this list. Now my favorite number to divide out, if you can, because usually it's the easiest, is 2. And you're going to do exactly what it looks like we're going to do. We're going to take 288 divided by 2, which gives you 144. Now, second rule says don't stop till you get a 1. That is not a 1, so we are not going to stop. We are going to add a layer to our cake, and we are going to see if we can divide a prime number out of 144. Now, kind of like I said on the last one, my favorite number to divide out is a 2. So if I take 144 divided by 2, we would get 72. That's also not a 1, so I'm going to add another layer, and we're going to keep doing this until we get to 1. So 72, once again, guys, I tell you what, probably the easiest thing to do most of the time, divide out 2's till you can't divide out 2's anymore. 72 divided by 2 is 36, not a 1. So we're going to add another layer. I could still divide out another 2. 36 divided by 2 is 18. We're going to add another layer. I could divide out another 2. 18 divided by 2 is 9. Now I get to the point where I can't divide out a 2, but I can divide out a 3. Remember, we are only dividing out prime numbers. 9 divided by 3 is 3. And whenever I add another layer, the only thing I can divide out of 3 is 3. And when I take 3 divided by 3, I get a 1. There's the one that we're looking for. Now, this is called the cake method because this is like a super, super tall birthday cake. That 1 right there is like the candle at the top. So you're not going to stop until you can put the candle on your cake. Now, the third rule says you're going to circle pairs. So what we did here is we found, and this is going to take it back to elementary school whenever you may have done this, or middle school, these numbers here, if you were to multiply them together, this is the prime factorization of 288. If you were to multiply 2 times 2 times 2 times 2 times 2 times 3 times 3, you would get 288. All of these numbers multiplied together give you 288. So what we're looking at, we're going to circle the pairs on the outside. So what this looks like is I have a pair of 2's right here. I have a pair of 2's right here. Now, this 2 right here doesn't have a pair, so I'm not going to circle it, but I do have a pair of 3's right here, so I'm going to circle that. Now, what we're going to do is, for your answer, you're going to have a radical sign. This rule right here says pairs go on the outside. So how this looks is I have a pair of 3's. Now, and I'll explain this here in just a second, but this pair of 3's is going to become 1, 3 on the outside of the radical. This pair of 2's is going to become 1, 2 on the outside of the radical. And that pair of 2's is also going to become 1, 2 on the outside of the radical. Now, anything without a pair, like that little lonely 2 right there, it's going to stay inside the radical. Now, the reason why the pairs become just 1 on the outside, keep in mind that I said if you were to multiply all these numbers together, you would get 288. So if I were to take all these numbers and rewrite them underneath the radical sign, okay, keep in mind that all of these numbers on the outside are technically still underneath the radical. So if I were to take that 3 times 3 and put it back underneath the radical, well, 3 times 3 is 9. And if you take the square root of 9, you get 3. So what happens is you have a pair of 3's under the radical becomes 1, 3 outside the radical. You could do the same thing with the 2's, right? This pair of 2's under the radical would be 2 times 2. Well, but 2 times 2 is 4, and the square root of 4 is 2. So see how the pair of 2's becomes a 2 on the outside. That's why the pairs become 1 on the outside. Now, whenever you have multiple numbers on the outside, or if you have multiple numbers left on the inside, you are going to multiply them. So this would be 3 times 2, which would be 12 square roots of 2. That would be your answer. We're going to get lots of practice with this, okay? Now, I think we're actually going to leave that second method for tomorrow when I return, and I'm going to show you that second method. So what I'd like you guys to do is I'd like you to go ahead and get this glued in, and I'm not on my normal computer, so I don't have my table of contents set up, but this should be glued into page 53 in your table of contents. So go ahead and get this glued in. It should be section 10.2, and it is simplifying radicals. So let's go ahead and get that glued in real quick, and then we'll jump over back to page 54 and look at our examples. All right, so we're going to start out with some pretty simple examples. So number 1, let's say we have the square root of 20. Okay, now the square root of 20. So what we're going to do is, what you need to do is we're going to cake any number into the radical. So give yourself, since our cake kind of builds up, you're going to give yourself a couple lines and you're going to write the 20 down below there, and you're going to start your cake. Now remember the first rule of the cake method, you're going to only divide out prime numbers. My biggest tip I can give to you guys today, divide out 2 if you possibly can. And I can take 20 divided by 2. So we're going to take 20 divided by 2, we get 10. We're going to add another layer. I can still divide out a 2. 10 divided by 2 gives me 5. We're going to add another layer. Now the only thing I can divide out of 5 is 5, and I get my 1. I get my little cake, or I get my little candle there. Now we're going to go back. You're going to circle pairs. So I do have a pair of 2's. The 5 does not have a pair. So for your answer, you're going to write your radical. The pairs, that pair of 2's, remember, this is like a 2 times 2 under the radical. 2 times 2 is 4. The square root of 4 is 2. This pair of 2's under the radical becomes a 2 outside the radical. Now this 5 is also a 5 under the radical, but if I take the square root of 5, that doesn't come out evenly. And if it doesn't come out evenly, we just want to leave it under the radical. So our answer would be 2 square roots of 5. Okay, number 2 says the square root of 200. Okay, so we're going to cake 200. So we're going to write our 200. We're going to divide out prime numbers. Once again, I'm telling you, do 2's if you can. So 200 divided by 2 is 100. Let's add another layer. I can divide out a 2 again, and we would get 50. I can divide out a 2 again, and I would get 25. Now when I get to 25, I could divide out a 5. 25 divided by 5 would give me 5. Add another layer, and I could divide out a 5, and then I get my 1. All right, so we're going to circle pairs. Remember, you're only circling pairs. So I know I have 3 2's right there, but I'm only going to circle 2 of them. But I also have a pair of 5's. So when you're done circling pairs, you have your radical. Okay, I have a pair of 5's, and I have a pair of 2's. You're going to multiply those together, and that 2 is going to be left there on the inside. So on the outside, 5 times 2 is 10, and then we get our square root of 2. So 10 square roots of 2 would be your answer. Okay, number 3. Okay, let's say here that we have 5 square roots of 32. Okay, now what you're looking at is you're looking at the numbers under the radical. I know you have the 5 on the outside. We're not going to worry about that just yet. You're looking at the numbers under the radical. Anything under the radical is what you need to simplify, what you need to cake. So we're going to cake the 32. So for 32, we're going to divide out at 2. 32 divided by 2 is 16. I could divide out another 2, I'd get 8. I could divide out another 2, I'd get 4. I could divide out another 2, I'd get 2. Divide out a 2 and I'd get 1. So a big cake of 2's. Remember, we're going to circle pairs. So I have a pair of 2's and another pair of 2's, and then I have 1 2 that's left over. So for our radical, okay, here's where that 5 comes in. So for my cake, I have a 2 and another 2, but that 5 was already out there. So it's going to be 5 times 2 times 2, and then I have a 2 left over on the inside. So your answer, 5 times 2 times 2, would be 20 square roots of 2 for your answer. Let's try another one kind of like that. So let's do -6 square roots of 90. So remember, for your cake, you're looking at the numbers under the radical. So we're going to cake 90. Okay, divide out. Now, I did say 2's. Okay, you technically don't have to divide out 2, so if you see 90 and you see that it ends with a 0 and you want to divide out a 5, you totally can. But keep in mind, it has to be a prime number. So you couldn't divide out a 10. 10 is not a prime number, which is why I like to do 2's. So 90 divided by 2 would be 45. Add another layer. Now we could divide out a 5. 45 divided by 5 is 9. Add another layer. I could divide out a 3. I'd get 3. Divide out another 3 and I'd get my 1. Now whenever I go to circle my pairs, I have a pair of 3's, and then I'm left over with a 5 and a 2 that don't have a pair. Now the biggest thing that you need to remember today is if you already had a number on the outside, don't forget about it. So I have -6 times, and then I just had a pair of 3's. Now on the inside, I had both a 5 and a 2. So we are going to multiply those together. So you would have -6 times 3 on the outside and 5 times 2 on the inside for an answer of -18 square roots of 10. Okay, now the last kind of layer here is going to be something that looks like this. So we have the square root of 49 x to the 6th. Okay, so of course we're going to throw some variables out there because how much fun would it be without variables? Oops, sorry guys. Okay, so first thing, just look at the number part. Okay, so I have 49. So if I were to cake 49, the only thing I can divide out of 49 is 7, and I would get 7. Divide out another 7, I'd get 1. Now when I go to pair things up, notice I've got a pair of 7's, which is going to go on the outside, and I've got nothing left over except that 1. If this happens, if you have nothing left over on the inside, it means that that number was a perfect square. Think about it. Square root of 49, it's 7. So if you recognize that you don't technically need to cake it, you could just say, well, the square root of 49 is just 7. Now let's talk about this x to the 6th. Under the radical, x to the 6th would be x times x times x times x times x times x. You're going to do the same thing we did with the pairs of numbers on the outside. You are going to pair up the variables. So if I pair up the variables, we'd have a pair here, a pair here, and a pair here. So what happens is this pair of x's becomes an x on the outside. The second pair becomes an x on the outside. And the third pair becomes an x on the outside. So I have 7 times x times x times x, which is 7x cubed. So with the variables, you're going to pair up the variables just the same way you do the numbers. Okay, let's try another one of those. So let's say we have the square root of 500 x to the 5th. So start with the numbers, and you're going to take the 500 and you're going to cake it. So if I divide out a 2 from 500, we'd get 225. From 225, I think it'd probably be easiest to divide out a 5, and we would get 45. I could divide out another 5. 45 divided by 5 would be 9. Divide out a 3 and another 3, and there would be our answer there. Now I can pair up the 5's and the 3's. So on the outside, I have 3 times 5, so we'd have a 15. Left over on the inside, we'd have a 2. Now, we're going to look at the numbers. Now, if you think about this, if it helps to write it out, your x to the 5th, that's 5 x's multiplied together. Out of those 5 x's, I could make 2 pairs. So on the outside, and I'm going to squeeze this in here, we're going to have an x squared because I have 2 pairs. But just like with the numbers, I have that one x that did not have a pair, so I'm also going to have that x left on the inside. Okay, let's just do one more. Okay, so number 7, let's do 10 square roots of 96 x to the 5th y squared. Okay, so let's start with the number first. Let's start with the 96, and let's cake the 96. So I'm probably going to divide out of 2. 96 divided by 2 would be 48. You can divide out another 2, you'd get 24. Divide out another 2, you'd get 12. Divide out another 2, you'd get 6. Divide out another 2, you'd get 3. Divide out of 3, you'd get 1. Okay, so when I pair up my numbers, we'd have a pair of 2's and another pair of 2's. Now remember that whenever you're pairing up numbers and putting them on the outside, if you already have a number out there, you have to include that in your answer. So on the outside, I'm going to have 10 times 2 times 2, which gives me 40. And I'm going to leave a little space there for my variables. On the inside, we have 3 times 2, which is 6. Now for the variables, with the x to the 5th, if you have 5 x's being multiplied together, you could make 2 pairs, so an x squared. But if you have an x to the 5th, you're going to have that one x that's left over that doesn't have anything to pair up with. And then for the y squared, right, 2 y's, you could just make 1 pair with nothing left on the inside. So it would be 40x squared y, square roots of 6x. Okay, keep in mind as you're going through this today, lots of practice over this week. So if it doesn't quite sink in today, that is perfectly okay. I should be back tomorrow for any help.